Good morning, everybody. Friday morning, Hall of Fame. We have with us Mahshad, Haeri, and Ryan Ellis for a panel this morning about a look behind Google's cloud. And I believe they have a slide presentation that they wanted to go over with us. Show us a little bit of an insight on Google's backend infrastructures and cloud technologies.
Good morning, everybody. I was warned about being this early. You guys apparently party too much the night before, so hopefully you're all awake. And I'm kind of a walker, so I apologize if I walk in front of you guys. But basically, what we're going to talk to you about is some of the backend stuff that goes into Google Cloud. And hopefully you'll learn something new about how Google Cloud is different than the other clouds that are around. But just to give you a little background on me and a little on Ryan, we both have been with Google for the past 5 years or so, doing what we call Google for Work and Education. And these are basically a set of applications that I'm sure you have all worked with in your private lives, Gmail, apps. I usually ask people if they have a Gmail account. I'm going to ask you guys, if you don't have a Gmail account, to raise your hand. You don't have one? Okay. So you're going to learn something today. And basically, when we joined Google, one of the things that we learned was how you really think outside the box. Because we all are told, oh, to solve problems that were created yesterday, you need to take your mind and put a different hat on and do different things and think differently. But when I joined Google, I realized that how that looks in real life. And they were not the first ones to do that, right? You guys are all in Full Sail. You know that sci-fi writers and creators have been thinking ahead. And they've been thinking about some of the things since 1960s that we use now. They were the ones who thought of cell phones, tablets, even Google Glass, right? In 1998, they had the first Google Glass. It looked a little different, but it basically variable computing as we know today. And of course, who can forget the way they amazed all of us by on-demand video instead of calling each other, right? But Google has been taking this a little bit further. We believe in this 10x thinking, moonshots, where we want to do things very, very differently. These are some of the research projects that Google X has been working on. And some of it might be familiar to you, some of it may not. The corner on the corner, you see this little lens. This contact lens uses the power of blinking to create enough energy to then analyze teardrops for people that have diabetes, so they don't have to poke themselves constantly to measure the blood sugar. They can do that from their tears. And then this will connect to hopefully one of the apps that you guys are creating on the cell phone, and then tells them when they need to get their injections. So what they all have in common, though, is the need to either get access to data, or the Loon project brings data to people that live in faraway places where cables can't get to. We can't bring fiber to New Zealand, for example. So these are being tested today in those areas. So people who are more and more connecting to the internet and to the world via these portable devices can actually get access to data. And I like this slide because it shows the variety of people that are using mobile devices today. We have more mobile devices in the world than people today. And we are expecting this to grow. And that's why you guys are in such good place for your future, because your careers are going to drive these, right? You are the ones who are going to create the next generation of these applications. And it's not just cell phones and mobile tablets that are going to be connecting to the internet. The Internet of Things are coming, things that are like your dishwasher is going to connect to the internet, right? Your thermostat. You be able to, the planes that are being created today can phone home and let Boeing know what kind of parts they need so they can ship them toward maintenance. So they're going to have the part that they need in the location that the plane is landing. So all of these things are going to need connectivity. And honestly, 10 years ago, Google wouldn't be able to support all of the connections that we have today. And based on Moore's law, our needs for internet connectivity and for computing grows or doubles every 2 years. So imagine what's going to happen in 2022, right? So what we're going to do is use cloud computing. Now, when you talk about cloud computing, a lot of people have a lot of different visions for what cloud computing looks like. This is Google's vision. We think that cloud computing runs applications on a shared environment where you then get served from a web browser, right? So there's nothing local on your machine that is interacting with your application. It's all done through a browser. And we've been doing this since the 1990s, right? The first search, Google search, came online because Larry and Sergey wanted to organize the world's information and make it useful. Yes, there was other search engines before them, but they were the ones who thought that they need to change the way indexing was working. And so they have done this, and if you look at Google webpage, it hasn't changed much, but that doesn't mean that the backend hasn't changed much. The backend has changed dramatically, a lot, right? So what does it look like today? It looks like a lot of computers, and we have many, many data centers that feed the websites that are around the world for many, many different countries. And it's not just search anymore. After Google put these data centers together, we started to look at other needs that people had. Indexing the internet was great, but what about videos? Today, 10% of the entire traffic, internet traffic, goes through YouTube. That's a lot of traffic. And I'm sure you guys contribute to that as well, as I do.
We are right now.
You are right now. Right. So 300 hours of video is being uploaded into YouTube every minute. Now, you guys understand video. You know how much data that is. And I'm not going to read the whole thing to you, but it basically is a lot of data, a lot of connections. We need to be able to manage this data, store it, and not just store it, but back it up, make sure it's always online. How do we do it? Well, we have global data centers that are all over the world. And when you travel to Asia, you can still go to google.com, gmail.com, get access to your email, not you, the rest of the people. But basically what happens is when you get to these, we connect you via fiber that is managed by Google. So this is something you may not have known, but Google we lay our own fiber under the ocean. We have to go fight our own sharks as they chew our fiber. But we basically own this, and we do that because it's really important to us to be able to connect all of these data centers together, because we treat these data centers not like a typical data center that you may imagine, a big building with a bunch of computers. They each do different things, and they have to be maintained differently. Some run Windows, some run Linux, some run other versions of Unix. We run the same machines that we try to use each data center as if it is one computer. It's really difficult. And we didn't start there, we started here. I really like this image because this is the very first storage unit that Google put together. Basically, Sergey and Larry put all the capital they were able to raise for their PhD program. And they bought 40 gig of hard drive space. Now, 40 gig is laughable today. We have more space on our phones than this. But this was 1996. Computers didn't come with gigs. They came with megs, or Ks even at some cases. So it was a big deal for them. And then they ran out of money, and they had to use Lego blocks and fiberglass to finish the chassis and make a case for the computer. And then they had to go beg and borrow and hopefully not steal, but who knows, computers to put the very first data center that they needed together. If you look closely, you see their Lego mans in the back of the entire the monitors there. But it's basically this was their first data center. From here, though, they learned a few things. They learned that it's cheaper and more effective to create their own servers. So they have been doing that since the 1996 first computer they built. Why did they do that? Multiple reasons. They didn't have money back then, so they had to do it. But now, even though they have all this capital, building your own machine gives you a lot of control. You can avoid putting things in the machine that is not used. So when you buy a server from Dell or HP, it comes with a lot of different ports and components that allows you to turn it into a mail server or a print server or a web server. But when you build your own, you can basically build a machine that does one thing really well. And you avoid putting extra components, capacitors, resistors, things that are going to create heat, use energy, and not do anything. So by doing this, we've been able to make our servers very efficient, both in energy consumption and cooling. We're also running our own hardened version of Linux on these machines. Why do we do that? Because when you have open source operating systems, you have a lot of control. We run our own tests to find vulnerabilities, and then we patch them real quickly. And because these are uniformly designed and they're all the same, we can patch them real quick. So when we find a security hole, we patch it in a matter of hours instead of weeks and months that usually takes to report it and then take the patch. So it's very, very well managed. And as I mentioned before, we treat these data centers as if they're one computer. So we basically use what we call containerization to run our software on top of these machines. Containers are very similar to virtual machines, except for the fact that virtual machines are designed to allow you to run different operating systems on the bare metal. So you can have a server and then share the components on that server, the CPU power, the memory, all of those, you can share with machines that do completely different things, right? That's virtualization. Containers share the same kernel. They run on the same operating system, but they run different pieces of different software. So in that case, you can use your computers a lot more because you have a lot lower overhead than virtual machines do. And then in our case, we're talking about thousands of machines, so this saves us millions of dollars. What happens, though, is when you give us the workload, like when you run a query in the Google search, when you go to check your email, the requests come to the closest data center to you, and then we have these cluster managers that will then decide where should this workload be processed. It depends on what you're trying to do, the job you're trying to do, how busy the data center is that's closest to you. Is it even working? Maybe the data center is completely down, and it will have to be dispatched to another data center. And these are all done through these cluster managers and load balancers that Google has created. And we have created an open source version of this cluster manager that we released to our to the world, and we use it for our platform, Google platform developers. Does anybody here know what Google Cloud Platform is? Right. So you know what I'm talking about, right? So it's also important to have your data available to you, right? Google doesn't use, we use backups, but not as our first choice. Backups we use as the very last choice. If something goes terribly wrong, then we reside to our backups. But we usually use spinning copies, multiple spinning copies, to create redundancy for our data. So when you save something in Google, depending on what application you're using, we create at least 6 copies of your data, 6 spinning copies of your data. We keep 3 of them in the data center that's closest to you, and 3 of them we save in a data center that's far enough that if there is a disaster, natural disaster or man-made disaster in the area that's closest to you, the other copies are not affected. So you guys live in Florida. There are a lot of hurricanes and storms that can take data centers out. We want to make sure that you still have access to your data. And the way we store data is also different. We don't store your data as a whole. So the best way I can describe this is, let's say your document, your email, is a piece of paper, is a file that you give me. When you give it to me, we do what we call sharding, which is basically just running the document through a shredder. I shred your document, then I dip it in an invisible magic ink that makes it unreadable to anybody but my magic self. And then I copy those shreds, which are basically the copies I was talking about, and then I mix them with other shreds that I've created from other people, and then I send the copies to another data center and keep some here. And then we store it in, let's say our data center is in New York, Empire State Building. We save these shreds in different file cabinets in Empire State Building. So now it becomes really, really difficult for bad guys to go in and grab a storage unit and have access to your data. When they grab a storage unit, if they get to the storage unit, all they have are these mixed up shreds. So what does this do? It makes it really secure, right? Because imagine, right now when you go home and you look at your laptop or your desktop or whatever you have that you store your data in, if I'm a bad guy and I break into your house, I steal that hard drive, I can actually get to your data somehow, right? Even if you encrypt it, I can try to break the encryption, and if I have powerful machines, I can basically do that. Cloud computing, through innovation and through different thinking, allows us to increase the security of your data. And it's not just that, it's the fact that we have so many people that are looking at after your data, and a lot of people cannot afford to hire all the PhDs that Google hires, frankly. I have a video for you. This is a good video that Denise is going to help me play, and this is going to show you some of the insights.
The engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
Yeah.
A data center's the brains of the internet.
The engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
It's row upon row upon row of machines, all working together to provide the services that make Google function.
I love building and operating data centers. I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center here in South Carolina is one node in a larger network of data centers all over the world. Of all the employees at Google, a very, very small percentage of those employees are authorized to even enter a data center campus. The men and women that run these data centers and keep them up 24 hours a day, 7 days a week, they are incredibly passionate about what they're doing.
In layman's terms, what do I do here?
I typically refer to myself as the herder of cats.
And I'm an engineer, hardware site operations manager.
We keep the lights on.
And we enjoy doing it.
And they work very hard. So we like to provide them a fun environment where they can also play hard as well.
We just went past the 3 million man-hour mark for zero lost time incidents. 3 million man-hours is a really long time, and with the number of people that we have on site, that is an amazing accomplishment.
I think the Google data centers really can offer a level of security that almost no other company can match. We have an information security team that is truly second to none. You have the expression, they wrote the book on that. Well, there are many of our information security team members that have really written the books on best practices in information security. Protecting the security and the privacy of our users' information is our foremost design criteria. We use various layers of higher level security the closer into the center of the campus you get. So just to enter this campus, my badge had to be on a pre-authorized access list. Then to come into the building, that was another level of security. To get into the secure corridor, which leads to the data center, that's a higher level of security. And the data center and the networking rooms are the highest level of security. And the technologies we use are different. Like for instance, in our highest level areas, we even use underfloor intrusion detection via laser beams. So I'm going to demonstrate going into the secure corridor now. One, I have to be on the authorized list with my badge. And then two, I use a biometric iris scanner to verify that it truly is me. Okay, here we are on the data center floor. The first thing that I notice is that it's a little warm in here. It's about 80 degrees Fahrenheit. Google runs our data centers warmer than most because it helps with the efficiency. You'll notice that we have overhead power distribution. Coming from the outside yard, we bring in the high voltage power, distribute across the bus bars to all of the customized bus taps that are basically plugs where we plug in all the extension cords. All of our racks don't really look like a traditional server rack. These are custom designed and built for Google so that we can optimize the servers for hyper efficiency and high performance computing. It's true that sometimes drives fail and we have to replace them to upgrade them because maybe they're just no longer efficient to run. We have a very thorough end-to-end chain of custody process for managing those drives from the time that they're checked out to the server till they're brought to an ultra-secure cage where they're erased and crushed if necessary. So any drive that can't be verified as 100% clean, we crush it first, and then we take it to an industrial wood chipper where it's shredded into these little pieces like this. In the time that I've been at Google for almost 6.5 years now, we have changed our cooling technologies at least 5 times. Most data centers have air conditioning units along the perimeter walls that force cold air under the floor that then raises up in front of the servers and cools the servers. In our solution, we take the server racks and we butt it right up against our air conditioning unit. We just use cool water flowing through those copper coils that you see there. So the hot air from the servers is contained in that hot aisle. It raises up, passes across those coils, where the heat from the air transfers to the water in those coils, and then that warm water is then brought outside the data center to our cooling plant, where it is cooled down through our cooling towers and returned back to the data center, and that process just repeats over and over again. To me, the thing that amazes me about Google and the data centers is the pace of innovation and always challenging the way we're doing things. So when people say that innovation in a certain area is done, that we've kind of reached the pinnacle of what can be achieved, I just laugh.
So I think that's good news for you guys, because innovation continues, so you guys can make sure you have enough to innovate for when you graduate. Can you click on the? Yeah. So one of the points that they made in this video that I think is really important for everybody is the effects that technology is having on the environment, right? We each know that everything we do, our cell phones, our computers at home, we all need energy. But we also know that there is a limited amount of energy in the world, and we want to conserve that energy, and we want to use clean energy when possible, right? Especially for the young generation like you are here, you really need to think about these things. And Google is trying to zero our CO2 footprint in the world by using clean energy, by using less energy, and by investing in wind and solar and renewable energies as much as possible. And you can read on the news, we just invested in a wind farm and a solar farm, and that work needs to continue. And one thing that's clear is that we cannot be growing our usage of technology without really thinking about the effect we are having on the environment. And by using things that are more efficient and more clean, we can really backpedal and probably repair some of the damages that we have done and prevent more damage from happening. So the example that's given here is a typical Google user uses, for a month of Google Apps usage, they spend as much energy as it takes to drive a car for 1 mile. Now, I was thinking about this driving from Fort Lauderdale to here. I drove 188 miles. I wasted so much energy. And I was thinking, with the amount of energy I used to fly from DC to here and then drive from Fort Lauderdale to here, I probably spent as much energy as I will use for the next 100 years to use Google Apps. So Ryan is going to take over and talk to you guys about some of the applications that are available within the Google Cloud. And of course, this is expanding and we are adding more and more, and hopefully you guys will add more to this. But he will talk about some of the applications that you can use, your parents can use, you can use in school or work or what have you to contribute to this evolution.
All right. Thanks, Mahshad. How's everyone doing today? Good, good, good. 9:30, so those hangovers should be trickling off at this point, if anyone has one. Not that anyone has one, but...
that was supposed to be a secret.
Okay. All right. Sorry. Well, as introduced earlier, my name is Ryan Ellis, and I'm with Google for work and education, and I actually sell the stuff that Mahshad knows extremely well, and I've gotten to know extremely well over my time at Google. You know, kind of taking off from the last point she made around her presentation relative to what Google is doing for the environment. Is anyone from Atlanta? Nobody. I actually live in Atlanta. One of the cool things we've done recently with our large data center, which is publicly known, actually Wired did an article a few years back about it. We partnered with the city of Atlanta to actually get used wastewater to help cool it. So I feel good every time I flush the toilet going to work for Google.
They clean it before.
But I'll take a kind of more of a front-end approach. So Mahshad told you about behind the scenes. Most of you are probably familiar with what I'll talk about, the applications, the services, what we coin the Google Cloud services that some of you may or may not use on a daily basis. So one of the things that Mahshad mentioned earlier is we joined Google to innovate, be a little bit different, think outside the box. That 10x type thinking is something that's ingrained in our culture that we thrive on every day. Whether you work on our advertising team, you're a core engineer, or you sell YouTube products. So one of the things Larry, our co-founder, has really driven down deep into our culture is incremental improvement, whether you're at an educational institution or a business, isn't good enough. So 10x thinking is something we should all strive for, because if you fall short of moonshot or 10x thinking, that's a pretty good miss. Whereas if you fall short of incremental or maybe 1x or 2x, what many old guard type companies strive for on a year in and year out basis, if you miss, that's status quo. Some of our really cool cloud services that it sounds like 99% of you use in the class or in your consumer lives, like Gmail, were formed, except one. That's why I said 99. Gmail was formed out of a 20% project, and it's something that Google engineers have available to them. So we have about 50,000 plus employees. Roughly about half of those employees are engineers, many of them with core competencies similar to yourselves, or that you all are going to full sail to accumulate. So Gmail came out of this 20% project, and we now have over 720 million users. Google Chrome has over 1 million users. It's now the most popular consumer and business web browser. We light up over 1.5 million Android devices every day. So the innovation behind our cloud that makes you turn on your phone, get an instant search, is something that a lot of times comes out of these really innovative, think different type ideas and mentality that we thrive on at Google. So I had to pick an area to focus on, so I'm going to talk a little bit about Google Apps for Education, Google Apps for Work. It's a suite of tools that a lot of businesses and schools and higher ed institutions are using. Mahshad and I work with a lot of large businesses, some of the largest businesses in the world, about moving from on-premise technology to cloud technology. And one of the big questions we get asked when meeting with executives is, why should we switch? Why is your cloud better than your competitor's cloud? Why does it make sense to partner with Google? And I threw up some of the things that I consistently hear post going Google, whether it's going to Google Apps, implementing our geospatial platform, using tools like Google Cloud Platform to build mobile applications. It's really a different way of doing business, collaboration, innovation, working the way you live. So when you're at home using Gmail, Drive, Docs, coming into your workplace or your higher educational institution, being able to use those same products is just easy. It's one less thing to think about rather than having two separate identities or lives. So the success we've had with Google Apps for Work and Education has been monumental. We've been in business within this little division within Google for about 7 years, and have grown exponentially. We now have a little under 2,000 employees in this division, and from a Google Apps standpoint, about 2/3 of the Silicon Valley startups, a lot of the apps that you all are using, started their companies on Google Apps. So Gmail, Drive, Docs. So there's a good chance they were never using a competitor tool. Over 58% of the Fortune 500 is using some sort of Google service, cloud service, within their four walls, globally or locally. And over 74 of the top 100 universities in the U.S. right now are on Google Apps for Education. We'd love to see Full Sail be number 75. So how many of you use more than one device per day? And I assume everyone has a smartphone in here. How many of you use more than 3 devices per day? 5? I'm on the 5. I have an iPad. I love my iPad. I have an Android phone. I have a MacBook. I have a Chromebook. And I have an Android Nexus 9, all for different areas of my house. Now, I also work at Google. I'm probably not the norm. I get the exact same experience no matter what Google service I'm on. So we're finding this more and more, not only from a higher ed standpoint, a K through 12 standpoint, but in the business world. Users are coming to work with tools that they're purchasing on their own. They're more powerful than many times than what they're given by their corporate IT departments. So being able to, again, work the way you live is fundamental. Accessing the files, the documents you need once you get out in the workforce, and as you're going through your education here at Full Sail, being able to do that seamlessly is really easy right now. The tools are out there. There's a lot of companies that do it. Unfortunately, many organizations still are heavily reliant with on-premise technology. So you might need to use a USB drive. You might need to create an attachment, go to a file server, get on an intranet. So working from home or working from the office or Starbucks sometimes can be a challenge if everything you rely on is located on a centrally locked down file server, at the company or school that you work at or go to school at. Funny thing that I saw the other day, and the first time I've ever seen it, is people like accessing their information anywhere, and we all know Starbucks has had free Wi-Fi for a long time. So typically you see people with phones or tablets in Starbucks. Well, no joke, someone brought in a tower, their 26-inch screen, set up shop, and I was in Starbucks for 2 hours. I thought it might have been the Starbucks that furnished this equipment. He said, no, I come in here every day, and I just drink coffee all day, and this is my place for business because the internet's so good. So being able to access data, for some people it might be on a phone, for others it might be on a traditional tower desktop, and it doesn't matter where you do it. The other part of kind of our suite of services is being able to store, share, publish information, finding the information you need at the tips of your fingers. So that powerful Google search that we all know and hopefully love is embedded within a lot of our products. So when you're looking to find a file or share a document that you created 18 months ago, you couldn't remember the name of it, it's a single, a search experience very similar to what you get with google.com to find that, share it out, universally collaborate on one document, and then seamlessly, close it down as a PDF if you want, or just share it out as a Google Doc or a Google Sheet. So what does this suite look like? This is what a lot of our conversations are about with educational institutions and work is, hey, we have a hodgepodge of tools in our organization. We're trying to get better sanction or security around it. Google, how can you help us come in with a platform? So, this is the suite of tools Mahshad and I talk about a lot, and it includes everything on here. So it's the exact same suite of tools that you get for free as a consumer. The only difference is we have enterprise wrappers and security controls around it. So you get things like Hangouts. How many of you use Hangouts for video conferencing? So Hangouts has taken off big within the enterprise. Google, most of our meetings are done over Hangout. So oftentimes I'm having a hangout. I'm in Atlanta, having a hangout with somebody in London. Someone else might be in Mountain View, our headquarters, and it's HD quality that you would expect. Being able to do that 4 years ago was really challenging or really expensive. So I don't want to make this a sales pitch because I'm a sales guy. It's kind of ingrained in me, but I've been at Google for a long time, as has Mahshad. We've talked to a number of K through 12, higher ed, businesses, and we'd love to take some questions here with our last 15 minutes about anything with Google. We might not be able to answer, but I know there are a few other Googlers in here who maybe can help us answer if we don't know. But we really appreciate the opportunity to come out and speak with y'all. And hopefully one day we'll be checking your resumes or applications at Google.
I'll get us started here. So it's not often you get to put Google on the spot. Google Fiber Orlando. Anyone? Yeah.
Google Fiber is an interesting. I was just in Austin. They just got selected to, and the challenges that they run into. I think you guys are a pretty good candidate because there's a lot of open land here. So vote for it. They ask people, residents, to vote. You should vote for Orlando. I think it's definitely possible.
I agree. Everyone on the interwebs watching, vote for Orlando. Google Fiber 20.
Orlando 2016.
So questions from the audience for our Google engineers here. We got a couple. I know you ETSC guys better be raising your hand right now. All right. We got a mic. Is Annie with the mic in the back?
Hi, I'm fielding questions from our online audience on YouTube. We have someone who's a really big fan of Google Docs, and he's wondering if you hope to expand the capabilities of Sheets to be a competitor with Excel, more things like charts and visuals.
So that's a really good question. We get that a lot. So one thing you have to consider is that when you are working with browser only as your UI, there are limitations that you run into that you may not run into when you have a desktop application. And for those of you who develop, you probably know what I'm talking about. When there are things that browser can support, and there are things that they really can't. So our goal with Google Sheets is not to replace Excel for those who use it as their power tool, but it is for us, the goal is to bring the capabilities, the basic capabilities, to more and more people that may not want to buy the expensive Office license, right? So we are improving Sheets capabilities, and we are working on the compatibility between Google Sheets and Microsoft Excel. But our goal is not to mimic everything that Excel does, because it already does it, right? It's kind of like when you go back to like, I don't know if anybody here follows painters, but when Expressionists came out, their goal was not to create a picture that looked like a picture because cameras already existed. Their goal was to capture the light, to create something new. And Google Apps is that something new. We're trying to bring things that, my mom, for example, she loves Hangouts. I was telling Ryan that she doesn't take phone calls anymore. She's traveling back home to Iran. I'm born and raised in Iran. And I called her, and she was like, Skype me. I'm like, Ma, I don't have Skype. I'm in the office. She's like, but I need to see you. I'm like, can't we just talk? She's like, but I can't see you. So the problem now becomes that everybody is getting used to these things. But the good thing is that these are easier. Like, she would never be able to use Excel, but she can use Google Docs easy.
And would it be safe to say that as browser technologies continue to evolve, that your ability to address some of the tools and functionality that might be
absolutely, yeah,
non-parity?
Just think back 5 years ago, right? With HTML5, a lot of capabilities improved, so we're able to improve with them. But
and this is a question we get a lot is, hey, our users, typically over 30, are very familiar with Microsoft Office. If Google Docs and Sheets comes in, there's going to be a revolution. Well, actually, most of what Google Sheets and Docs can do can replace 80 to 90% of what Microsoft Office can do. And that's good enough, because when you're an organization looking to reduce costs, increase productivity and collaboration, it's a really, really good thing to take a look at that and maybe say, maybe these users don't need tools like Microsoft Office.
Hi, I was wondering what type of, I'm trying to think of it right now. I'm sorry, I just went brain dead. What type of Linux you guys use for your servers, as in like Ubuntu or Debian for your data centers? Like, cause you guys said you were custom built Linuxes for the data center. So I was saying, if you guys use Ubuntu for that or other.
Yeah,
guys, okay.
We use Ubuntu. We use different versions of it. If you go to Google developers.google.com, you can see that we also provide virtual machines on top of our infrastructure, and some of the versions of Linux that we provide are also there. So you can go and see what kind of virtual machines you can run.
Thank you.
Hello, I'm Ketan. Since there's rise of Internet of Things, there are so many devices. Google develops a software, and there are hardware supporting Google software. For Internet of Things, how's the standardization happening? Because most of the software won't work on some kind of hardware. How do you patch up that?
Yeah, that's a good question. It's kind of like what we work on are APIs, right? So one of the APIs that Google Cloud Platform provides are called endpoints. These endpoints give you hooks for your devices to create connectivity, and we do the data transfer using JSON and some of the standards that transfer the data without you really needing to think about the data structure of the source or the destination. So you just pass it on using these endpoints, and then we process it on our end. Does that make sense?
Hi. I've used Google Cloud Platform before and like their services and everything, but I wanted to know what's really the deciding difference between Google Cloud Services and other services that exist out there, like Amazon Web Services or VMware data centers or things like that, because I've seen that they offer similar things, but what really would be an advantage versus that some competition like Amazon?
So a lot of what I talked about, like us laying our own fiber, the way we manage data, the way we create our own servers and run them, and all of those. When you go to Amazon, what you get is you can stand up your own virtual machine and run your stuff. So theirs is very different than ours. If you look at our cloud platform, we provide you with a set of virtual machines that we run and manage, and we give you that choice. For Amazon, it's different. You can bring your own virtual machine and run on their backend. But I guess ours is different from ground up. We have developed these big data centers, and we've been running these web services and cloud services since the 17 years ago when Google was created, because the way we were thinking about search was really what we call web services today, right? We were thinking, oh, this has to be global, this has to be equally available to everybody, we need to index this differently. Even the way we create our index is different, right? So from that, like VMware is a good example. I used to work for EMC, and I was very well knowledgeable of VMware. I'm not that knowledgeable of VMware since 4 or 5 years ago. But what they did is you basically create a machine. When you run these virtual machines on your hardware, you're basically over-allocating, blooming basically the memory, and then these machines compete with each other to grab the memory. So it can work really well if your applications are not very demanding. But if your applications that are running on these virtual machines are demanding, they start to compete with each other, and your performance degrades, right? Google doesn't do that. We say, OK, we're going to manage the allocation of these resources at a hardware level. And for services that we run, that's very well done because we control the entire stack. Now, when you create virtual machines on our hardware, then you may run into some of those issues. But we try to avoid that by doing it different. So we don't use VMware as our virtualization software. We created our own because we wanted it to work well with the way we manage our own stack of software. So it's hard to compare them like Apple to Apple because they're really comparing apple to eggs. They're very different. But they each provide a set of services that you can, and then it's up to you to look at the performance, the price, how they fit what you need. Maybe if you have a global application, you need to really think about like what are the connectivity issues that you're going to run into if they don't have their own fiber, for example.
Would it be safe to say then, to add on to that the demographic is a little bit different? It's a needs analysis problem. Like Google services are more targeted towards a solution to a specific need versus an Amazon solution, which is maybe more holistic in their approach.
Well, I think the way we are looking at it really is we think that everybody is going to move the way we are thinking, right? Because we think that everybody wants to utilize the hardware as much as possible, and we don't think that at some point it's easier to do the way we are providing it, and than the way some of the other competitors are managing hardware and software, right?
Sure.
But it's really a different way of thinking. We're going this way, they're going that way. Yeah, but you're right. It's very much depends on what you need exactly at the moment.
We got bright lights.
So I'm in the film program, and so I was wondering how like Google, like the cloud, will start being integrated into like the entertainment industry when it comes to collaboration and serving like video files to a point where if someone's doing a production in like LA, but everyone else is in like New York working on like the edit of it, and how it would come into play there.
That's a really interesting question. Photoshop just created a Chrome application, so you could do what you just described using the web browser. You put your file in a location, and then your friends and you can work on the same picture together, which was revolutionary in my view. And it shows that Adobe is thinking about, oh, this is the way of the future. Desktop applications are going away. What Google can do is we can create the infrastructure in the backend to store your files, which we have. We have what we call cloud, Google Cloud Storage, which is think of it as a bucket that you can put your stuff in, and the files can go as big as 5 terabytes in size per file, right? So I don't know how large your movies are. I'm guessing that's like 100 movies or something. So these files then can be accessed from anywhere in the world based on your access rights. So you can put your movie up there and give your friends access. The application, Google may not be the best company to create a photo or video editing application because we don't have the competency in that, right? It's you told me some of the ones that you use.
I think we use in your film Final Cut. You use Premiere, After Effects, and the Adobe Stream process and that kind of thing.
So one thing you may not be able to collaborate live like you do on Google Docs because Google Docs is much simpler. When you're editing a movie, I'm assuming you want to check it out and like lock it and then make your changes and then put it up there and then have somebody else. But that's the future, and I think you should ask whoever your software provider is if they're thinking about that.
I think you brought up a good thing with Adobe there. Adobe did it with Photoshop. So this comes back to, I think, what we talked about earlier with the browser question. And once bandwidth starts to become a little bit more prolific, and we have fiber in Orlando and other places, then working with such large pieces of data like a video, you'll see them expand that same technology into other things. And Google Cloud Storage might be a good mechanism to actually transfer those files. And would it be safe to say that Adobe and other large companies like that are also customers of yours that utilize some of these backend services behind the scenes that they might not even know about?
So we come to market with the horsepower, to kind of answer your question, if we're doing anything, we have the infrastructure, Amazon has the infrastructure. That entire industry is something that is going through rapid change right now. So I think you have a great idea. You might get bought by Google or Amazon one day.
Yeah.
But we have the horsepower and infrastructure to host your idea.
You should get together with some of your developer friends.
Right across the aisle, we have the ETSC people here. You do get together and work out something.
Hi, my name's Andrew Monroe. I've been using the consumer side of your apps for a little while. I saw you had office work apps as well. What are some of the differences between those? What extra features does the business side get?
The business side really gets, the big thing that they get that you don't get with consumer is, once they get unlimited storage, and 2, they get an admin console that allows them to turn things on and off, configure things. If they want to allow only internal sharing within an organization, they can turn that on. So they get a lot of auditing and configuration and controls that you as a Gmail user don't have because Google controls that for you.
And you get to keep your domain. So it wouldn't be at gmail.com, it'd be fullsail.com or fullsail.edu.
Right.
How are we looking at questions? We got anything else? Okay. Well, we're getting right about that time anyways. I'd like to thank both Mahshad and Ryan for joining us this morning. Let's give them a hand. Very enlightening, and Google Fiber Orlando.
Yes.
Thank you. Thanks for joining us, everybody.
Thank you, guys.
Thanks, everybody.
Thanks for your time.